Can someone tell me what the formula for area of a square or a rectangle is? Annie? Oh, sorry. I didn't see your hand. Go ahead. Length times width. Okay, so the length times the width. Is there anything special about squares and rectangles that might be important for us or help us not do a whole lot of work? Start with a square. What's super important about a square? Tori? All sides are congruent. So if you know it's a square and you know the distance of one side, then you know the distance of all the sides, right? What? Yep.
I'm curious to know, how many of you put length times width times height? I saw some.
Oh.
I'm just wondering how many. And if you know what the difference of the two are. That's kind of important. Or just didn't have length times width, but you didn't remember what it was. So, we're all good? Okay.
All right.
Go ahead.
What about rectangle? What can you tell me about a rectangle that's important? No? No one knows anything special about a rectangle? Tori? So two sides are congruent, right? Opposite sides are going to be congruent to each other. So if you know the short side, you know the other short side automatically, right? Or long side versus long side. Okay, so length times width, base times height, you can write it that way. Either one's fine. I'm going to write it up here. So area, rectangle. All right, this one's always fun. What is the area formula for a triangle? Okay, so we can write it as 1/2 the base times the height. Did someone write it a little bit different but have the same thing? You wrote it two ways? Okay. Base times height divided by 2. Did we have that? Good. Now there's something really important about the formula for area of a triangle. There are a couple different types of triangles that we could see, right? We could look at a right triangle. We could look at a triangle like this. Actually, I'm just going to go with those two for now. Okay, so base times height. Which one is the base and the height in the first triangle? What would be the base and the height in the first triangle? Okay, so I'm going to ask you about the second triangle then. What's the base and the height in the second triangle? Crickets. Great.
Yes, yes.
Oh. Okay, so you're going to say this is the base. The height goes there. Okay. So let's go back to the first triangle. I would write this down, by the way, if I were you. What about the base and the height in the second triangle? Okay, we're going to call this one the base. And which one would the height be? Now, because you're multiplying, if you mix up the base and the height, you're going to be okay. Because what's 2 times 3? And what's 3 times 2? 6. So it doesn't matter in which order you multiply. Here's what you need to write down. Ready? This is an important note. Everyone ready? Everyone's writing down what I'm about to say. The base and the height of a triangle. The base and the height of a triangle create a 90-degree angle. The base and the height of a triangle create a 90-degree angle. Super, super, super important. Which means in this problem, in this triangle, my hypotenuse is never going to be my base or my height, because that doesn't create a 90-degree angle with either of the other two sides. Okay? In this problem, these two sides here are never going to be the base or the height because they don't create the 90-degree angle. So you're looking for the two sides that create the 90-degree angle in order to find the base and the height. Everyone okay with that? Awesome. Okay. You have your note sheet in front of you. So it's similar to yesterday's homework where we need to start by plotting those points. So I'd like everyone to take a second and plot those points. But before you do, how many points are there? 4, which means the shape of your triangle is going to be what? Could be a square, could be a rectangle. It's a quadrilateral though, right? It has 4 angles, 4 points, so it's gonna have 4 sides. So everyone take a second and plot those points. You're going to be able to see it a little bit better on your paper, but it should look something like this. Now in geometry, we can never assume we know what the shape is, but what does it look like to you? Probably a rectangle, right? 2 sides look shorter than the other 2 sides, which means we're going to have to find the length of just 2 sides. So what 2 sides are going to be equal to each other? What 2 sides are for sure going to be equal? Okay, I'll start you with 1. What would CB be equal to? What was that, I'm sorry? AD. So CB and AD are going to have the same length. CB and AD. What else will have the same length? DC and AB will have the same length. So we can either use the Pythagorean theorem or we can use the distance formula. We have a preference? Okay, I knew that was coming. What would you like to find? CB. Okay. So if I'm looking for CB, remember you're creating that 90-degree angle. How many units up do you go? 2. How many units across do we go? 2. So Pythagorean theorem says a squared plus b squared equals c squared.
Are you using it at the top?
Uh-huh.
Okay.
So 2 squared is 4 plus 4 is c squared. And what is 8 squared, or the square root of 8 to the nearest 10th? I heard 2.8. Anyone want to confirm that? Okay, so CB and AD are both 2.8. Both of those line segments are 2.8. I want you to find the distance of either DC or AB. Actually, can the first 3 groups and then group D, I want you to find AB, and then everyone else I want you to find DC. So find the length of AB, the first 4 groups, so the front 3, and then this group here, and then everyone else find DC. So AB and then DC. Okay, someone from the first 4 groups, what was your answer for AB rounded to the nearest 10th? Haley? 4.2. 4.2? Did we all get that? Someone from the last set of groups, what was your answer for DC? 4.2. Does it make sense that they're the same? They should be, right? They're equal sides. It's a rectangle. So all of you should have gotten 4.2. So you found that you went up 3 and over 3. So 3 squared plus 3 squared equals c squared. Or 9 plus 9 equals c squared. Or 18 equals c squared. And you end up with 4.2. Now the directions at the beginning tell us to find the perimeter and area. How do we find the perimeter? Add all the sides. Now as you're doing this, make sure you add 4 sides together. You should have 2.8 plus 2.8, or you can write 2 times 2.8 because they're both the same. And then you have 4.2 plus 4.2. What do you get for the perimeter of that figure? Darian says 14. We agree with that? Okay. So the perimeter is 14, and we don't have units, so we're going to write in units for perimeter. We also have to find the area. And you told me in the warm-up the area was length times width. So what's the length of this rectangle? Okay, 4.2. What's the width? 2.8. If you said it was the other way around, is that okay? Yep. What is 4.2 times 2.8 rounded to the nearest tenth? 11.8. Does anyone know what units are for area? Units squared. So if we actually know the units, we would put yards or inches or what have you. But since we don't know the units, we're going to do units squared. We're good with that? All right. Number 2, I have 3 points. What's the shape going to be? Triangle. Let's take a second and plot those points. 2, 2. So what I'm going to give you a second to do is I want you to find the length. Well, actually, I'm going to ask you first. How many sides do we need to find the length of if we're looking for perimeter and area? All 3 of them, right? Because perimeter, we have to add up all the sides. Are any of them horizontal or vertical? Nope. So you're going to either have to use the distance formula or Pythagorean theorem for all of them. So I want you to find the length of DE, the length of EF, and the length of DF. So take a second, or a lot of seconds, to find the length of those 3 sides. Distance formula or Pythagorean theorem. DE. I'm assuming you all still went with Pythagorean theorem? Okay. How many units did you go up for DE? 5. And over? 4? So 5 squared plus 4 squared?
All right, everybody? Just one person did it.
Just Sophie did it. So 25 plus 16 equals c squared. So you get c squared equals 41. And when you take the square root, what is the length of DE? 6.4? Someone confirm that? Okay. Someone other than Sophie. For EF, how many did we go over? Over?
Over, not down, over.
For EF? You went over 2? Did I plot it wrong? I did. Okay. You went over 2, and you went up how many?
7.
Okay. So 4 plus 49 equals c squared. And then c squared equals 53. What'd you get when you took the square root? 7.3. Great. And then df, how many do we go over? 2. Up?
2.
Great. And we already did that one up above, right? So you should have gotten c equals 2.8. Okay, perimeter. Add up all the sides. So 6.4, 7.3, 2.8, and you got what? 16.5. Now, for area, which 2 side lengths create the 90-degree angle? So tell me the letters. What 2 side lengths create the 90-degree angle? DE with DF, which means that is your base and height. So DE is 6.4. DF is 2.8. And we divide all of that by 2. So 6.4 times 2.8 divided by 2, rounded to the nearest tenth would be what? 6.4 times 2.8 divided by 2. So it's 8.96, but if you round to the nearest tenth, the 6 rounds the 9 up to a 0, which then technically rounds that 8 up. So your answer is going to be 9.0. All right, last one. Yes.
Can we clarify something real quick?
Yep.
You drop back up for a second?
Uh-huh.
So, real quick, something to classify also, if we know that our triangle is going to be a right triangle, if you think that through for just a moment, your longest side, if you're not sure which one to use, just remember your longest side will always be your what? Your hypotenuse. So if you're not sure, look back at the answers. You have 6.4, 7.3, and 2.8. Which one's the longest? 7.3, which is EF, and that is this side. So if this is my hypotenuse, your other 2 have to be your length. Does that make sense? So that's another trick if you're not visually seeing it. So we tried to, she gave you a couple already, and that's another one too. So make sure you use those for tools, okay?
Are we okay with that? Mm-hmm. Awesome. All right, last one. Let's plot these correctly this time. Here we go. 2, 2, 10, 2, 4, 1, 2, 3, 4, 5, 10, 2. Okay, so here is this triangle. Well, one of the sides is pretty much given to us, right? We just have to count the boxes. What side is that? AB. So take 1 second, take 3 seconds, and count the length of AB. Let's start there. Because there's no math, it's just counting. What's the length of AB? What do we get for AB? 8. We okay with 8?
Yeah.
Okay. So AB is 8. We need to find AC, and we need to find CB. Now, instead of all of us doing both of them, the first 4 groups, so again, the front row, and then this group here, you guys are going to find AC. Everybody else is going to find CB. Okay, so the first 4 groups find AC. Everybody else find CB. So we have AB is 8, AC is 8.1, CB is 8.1. So perimeter, add up all the sides. And what do you get? 24.2. We forgot to add our units up here. I'm going to fill those in. Okay, and for area, let's think about area for a second. I need a base and a height. Who can tell me what the base is going to be? 8. We agree that it's 8. What's my height going to be? Where'd you get 7 from? Because I don't see 7 here. So you have the line that goes through the triangle and creates that 90-degree angle. So you're going to count those boxes, and if you count them, you should get 7. All divided by 2. 8 times 7 divided by 2 gives you what? 28 units squared. The questions on your test are going to look very similar to the ones I just did with you. Yes, ma'am.
When you put our answers in like the 28, do we have to put in like a unit square or units?
No, we'll probably have the units like at the end of the box for you. You don't have to worry about the unit. I'll make sure when I type it up, I'll tell you guys for sure, but I don't think you'll have to add the units for this one. Okay? Any other questions? All right, we have about 7 minutes left.